Okay, we're back here, part two of some of the supplements you could use to help students understand a bit more of the content involved in the heating of their universal dwelling, get into those heat standards. Uh, we'll talk about standard 3.2 a bit more. Heat transfers from hot or colder until thermal equilibrium is reached. And you can see I highlighted or changed the color of these terms because these are some important terms that you probably want to put on your word wall to help not just your ELLs, but just your general ed students will probably not be familiar with these terms as much. But to go through them, what I like to do is thermal. I'll talk about words that have thermal in it, like a thermos or a thermometer or even thermal underwear, long johns. And as students, a bit about those items, what they do. And most students will start to talk about, either they measure temperature, or they keep things hot, those sorts of things. And so I say, yep, that's exactly right. Thermal is related to heat. That's what that term means. Thermal means heat. And then for the term equilibrium, I show them that it has the beginning of the word equal in it, ask them what equal means, and some students will begin to say, oh, it means the same. And I say, exactly. That means when things become the same temperature. And then we can move into our notes and talk about how, heat's transferred hot to cold until things become the same temperature known as thermal equilibrium. Then there's no more heat transfer. So I found these images online, but it's good to have some visuals included with your notes. And so, we take some notes, heat transfer hot to cold, thermal equilibrium, things same temperature, then there's no more heat transfer, stuff like that. And one way I like to start the beginning to talk about this is by passing around the ice pack at the beginning of class. Obviously keep the ice pack cold till you start the class and pass it around. And I just ask students as this is happening, what do you feel and why is that happening? How does the ice pack make your hand cold? Because, obviously that's what's going to happen there as they hold it. And you get to this common misconception students still have at this point where the cold is transferred. Cold is coming out of the ice pack into their hand. And so I like to start with that and then talk about the fact that heat's always from a hotter to colder substance and how that works when they feel and they touch something and it feels cold, and discuss that the heat's actually leaving their hand. That's why their hand's getting cold. It's not that cold's going into their hand, it's that the heat is leaving their hand. And then talk about how the ice pack might feel a little bit later. It got warmer, and relate that to how, okay, heat went into the ice pack from your hand. And even relate this to equilibrium. So, I like to start with that. It's a fun little quick thing to do as students pass around and get the discussion going. All right, and then I'm fortunate enough to have just a few of these apparatuses here. Flynn Scientific carries them, but even if you don't have these it's just styrofoam containers in a metal little like bent rod that could transfer from the heat to the cold, and you can see the temperature decrease and increase here. But even if you don't have these around, I found a cool site that right here that shows you how to make them very easily using some wire, styrofoam cups, bending the wire, hot and cold, and it has a lab there to share with students. In another lab you could use where you submerge cold water into warmer water using two thermometers, and the lab students take the data. And basically, again, we're just taking data with students, showing them heat going from the hot to cold, the hotter temperature going down, the colder temperature going up, discussing, what we learned about heat transfer, that standard 3.2 with students as they do these labs. So, I like to do this lab with students and, have them collect data, graph, and they should see something like this where the warm object begins to get colder, the cold objects begins to get warmer, and then they meet here at thermal equilibrium, some temperature. And so this site, Physics Classroom, has some good material you could find to supplement some good text. If I just show you real briefly, I'll talk about this site a little bit later. But yes, the physics classroom has a lot of content in there. So if you're trying to supplement the textbook, you could pull up some reading from this. It talks about heat, thermal equilibrium, hot to cold. So you might want to take a few things. It goes in probably a little more detail than what we need for ninth grade. But, there's a few paragraphs you could pull from here and have students kind of read together as a class. So I like to supplement with that as well, the physics classroom. And then you could take this a step further and start to address that formula that they'll see on their MCAS formula sheet, Q equals MC delta T, or as students like to say, triangle T. Heat, how do we calculate how much heat? And so as they're doing the lab, or even if you have them just do another lab, like mix in hot and cold water lab, you could find these labs online. But basically, they take data, then they use that data to find how much heat energy was transferred. Okay, so how much energy was gained by the cold water, how much energy was lost by the hot water, and those energies should be, in theory the same, but at least close to the same when they do the lab, because when you do labs, there's always room for error there. So they take the data and then they calculate using the specific heat of water. So it's a good way to have them take this a step further and actually start using that formula. So this is a good time to do that while they're doing these labs and they're seeing heat transferred from a hot to cold substance, temperature changing. They can actually use that change in temperature, and you could introduce specific heat, just briefly say, okay, this is a property of a material. We'll get a little bit more detail in that, and as we go through the next few lessons, because they're going to start actually in the next lesson talking about this a bit more. So when we get to that lesson, we'll go through that. But you might want to introduce a lab like this where they actually start to use that and do some calculations, because as I mentioned in a previous video, this formula and this calculation is not introduced to actually much later in the year. So I like to do a little bit with it now while we're talking about heat, having it in context for them. And this is a good point to do that while they're doing these little labs here and collecting data, using that data to actually now calculate. So, taking another day to go a step further with students, and just using this formula now, and then we could always go review through it again when it's actually introduced much later in the curriculum. So before I run out of time, we'll go to the next standard, how to supplement the next standard, the 3.3. So check out the next video and we'll go through that.